So how the packets are forwarded, we saw when packet is received from a computer that 7-layer properties are there in each packet. First, the router 1 receives the packet from the PC 1. Router 1 de-encapsulates it, meaning it opens the packet. It goes up to layer 3 to find the destination to where the packet needs to be forwarded. After knowing the destination is what? 192.168.4.10. After knowing destination, it looks into the routing table, and routing table says you need to send it to router 2. Router 2 receives it, but before sending to router 2, what router 1 has to do? Because it has opened the packet, it has to close it, meaning it again encapsulates. It encapsulates with different layer to address. It encapsulates with R1's F01 interface MAC address as the source, R2's F00's MAC address as the destination. We spoke about this in the previous class. So the MAC address will change from hop by hop, but the IP address source and destination will never change in the packet. Very important thing you should remember. IP address will never change till it reaches the destination, whereas the MAC address will keep changing for every hop. Right? And also, see, it looks into the routing table. From the packet, it checks the destination IP. This is what I just told you. Router 1 received the packet from this PC, and it looks the destination IP address. It finds it. Now it goes and checks the routing table. This is R1's routing table. 192.168.4.0 network is 2 hop away. You see, 1, 2 hop away. If you go to 2 hop, you will find that 2 hop away, and the packet needs to be sent to the next router, 2.2, and it has to be delivered, or it has to be sent out via this interface F01. So from routing table, it gets all the info to which exit interface I need to take, to which next router I have to send, what address I have to send, everything. Now with that, it comes to router 2. Again, in router 2 also the same process repeats, goes to router 3. You see, in router 2 also it looks into the destination IP address, checks the routing table, forwards to router 3, and so we saw this picture also in the previous class. We also saw the difference between metrics. Metric of RIP is hop count. Metric of OSPF is cost calculated based on bandwidth. Now, if you see a hop count as the metric, then you will say this as the best path. It's just only one hop. But see the bandwidth, it is too narrow. It is too narrow. In that case, you can use OSPF as a protocol, because OSPF will look into the bandwidth. Here it is 1500 kbps. T1 means 1500 kb. So bandwidth is really very big here. Even though the number of hops are more, the time taken to go through this path will be less. I told you, no? What is the use of going in a bus which goes through a market? It may be just a short distance via the market, but it's a market, congested area, no much bandwidth. Even there are 5 stoppings, you will prefer to go via other route, not via market route. Sometime in the market, you will not have space to go. You have to wait for people to move away. Long time you have to wait. That is why we have different protocol with different metric. Whichever suits your requirement, you will pick that protocol. In networking, load balancing is allowed. See, there are 2 people going to your relative's house, and you want to send 10 kg rice to your relative. You got some special rice, red rice, and you want to give 10 kg to your relative. So from your house, there are 2 people going to your relative's house. Instead of giving the whole 10 kg to one person, you will divide it into 2. 5 kg in one bag, 5 kg in another bag. And you will send 5 kg with one guy, because both are going to same destination. So to one person you will give 5 kg, to another person you will give another 5 kg. What is the advantage? They can walk fast. If you give full 10 kg to only one person, then because of heaviness, he will walk slow. Likewise, when you have multiple paths, redundant paths, assume that you don't have this path. When you have multiple paths with same metric, you see, here also T1, here also T1, T1. For example, to go through this path, if it takes 5 seconds, to go through this path also, it will take 5 seconds only, because the metrics are same, the bandwidths are same. In such scenarios, the routers will show 2 paths in the routing table. R1 will say, to reach this destination, you can go here and here. So if routing table shows 2 paths, then packet can use 2 paths. Packet will be forwarded using those 2 paths. At last, we also spoke about administrative distance. What is administrative distance? Administrative distance is a numerical value given to each protocol. When there are multiple protocols providing route information, router will prefer the route given by the protocol whose administrative distance is less. Now tell me which route source is more trusted in this table. In this table, see the table. Which route source is more trusted? Internal BGP or connected? Connected, because it has got zero administrative distance. Lower is always preferred. See, connected. யாராவது சொல்லணுமா கனெக்டடுக்கு இது அந்த வழியா போங்க போயிடலாம் அப்படின்னு யாராவது சொல்லணுமா கிடையாது கனெக்டட் யூ நோ இட் வெரி வெல் இட் இஸ் கனெக்டட் no one need to tell you no routing protocol needs to tell that to go to the destination you go via this place this wire for connected network router itself knows there is no need for any other protocol to tell. That is why for connected, it is given 0, means most trusted. Fine. See the question again in the below. Which route source is more trustworthy, internal EIGRP or OSPF? Prem. Why? You understood the topic very well. Nice. Okay. Now, if you take a routing table, which is there in the router, they maintain the routes. Routing table maintain the routes. What does that mean? Routing table maintains the route. This routing table stores the information for the directly connected routers, directly connected network, and the routes learned from the remote through some routing protocol into RAM. So where is the routing table maintained? In the RAM, random access memory. Now, in the routing table, we saw in one picture here, see this routing table. In routing table, it has got routes. It says, you want to go here? Okay. You should go to this next stop. This is the IP address of the next router, router 2. And what exit interface you have to take? You have to take this exit interface. So that is what routing table will have. Routing table will have how far means the metric and who is your next router to where you need to go. See, you may have another router also here, another router also here. If you go this direction, you will go only Tirupati. If you go this direction, you will go only somewhere, Pondicherry. So it very clearly says go via F01. And when you go there via F01, you will find this guy, router 2. Deliver it to him. He will take care. And what he does, he also looks into the routing table and he delivers here. And then this guy delivers here. So that's what routing table will have. See, routing table contains next hop address that will take you to the remote network. All right. Okay. In the routing table, you may see in the routing table L, C, S, D, O. O means OSPF given routes. D means EIGRP given routes. என்ன நியாயம் சார் இது, அநியாயமா இருக்குது. ஸ்டாட்டிக் எஸ்ங்கிறாங்க, நல்லது. டைரக்ட்லி கனெக்டட் சிங்கிறாங்க, நல்லது. லோக்கல் ரவுட் இன்டர்ஃபேஸ் எல்லுங்கிறாங்க, சூப்பரு. ஓஎஸ்பிஎஃப் ஓங்கிறாங்க, ரொம்ப சூப்பரு. இஏஜிஆர்பிக்கு என்ன சார் இது அநியாயமாகுது, டீன் போட்டாங்க. ஈன் போடுறது தானே அப்படின்னு நீங்க கேட்கலாம். என்ன கேட்ட, அதுக்கு ஏதாவது பதில் இருக்கா உங்ககிட்ட? இல்ல வெங்கட், EIGRP uses one algorithm. That algorithm, that EIGRP's algorithm is known as dual. Dual diffusing update algorithm. Dual. EIGRP uses an algorithm to find the best path. That algorithm, see, D. That's why dual algorithm. Now, look into this routing table. It's the routing table taken from router 1. It says dual algorithm, means EIGRP, has given route to reach this network 10110, this network here. To reach this network, see 90. What is this 90 means? EIGRP's administrative distance. And this is the metric. You see EIGRP's metric. And what path it will take? It will take the path whose next stop is this one. And this route is learned 5 seconds ago. And what is the exit it will take? It will take this exit. Repeating again. This router learned from EIGRP about this destination. When? 5 seconds ago. As what? As this much as the metric to reach that via router 2, which is the next hop, needs to be sent out via serial 00. You understood this? This is how you need to understand the route in the routing table. Yeah. So you have a route timestamp, means the metric. You have the outbound interface, outgoing interface. You have next hop address. Sorry, routing timestamp means from how long you know this. That is routing timestamp, route timestamp. When did you learn? 5 seconds, I know this. For 5 seconds, I know this. Metric and administrative distance. And who gave this route? D, means EIGRP. That is the route source. To which destination? Yeah. So this is how you have to understand each line in the routing table. This is what we call it as root. This is one root in the routing table. You understand? See, for directly connected, you have C 192.168.10.0. You see, 10.0. In that, what IP address on the link locally? Locally, what is the IP address on the 10? It is 1. So for all the connected, you will also see L. You can ignore it because it's the same thing. This is the network. This is the IP on that interface of the network. See, both are on same port, G00. So both talks the same thing. One is talking about the network. The other one is talking about the IP on the link. So this you will see only from iOS version 15 onwards. In the older versions, when we were learning, when I was like you, I never saw L in the routing table. I see only C, O, D, B. I never saw L because in those days it was version 12, 12.0, 12.1. But now you got everywhere, nowhere 12 you see. You see everywhere 15 later version. In this version, you will also see L, which is talking about the IP address on the port. So the directly connected, if you see here, this is 10, this is 11. So there is a 10 network, there is 11 network, there is 200 network. But for 200 network, if you notice, they have subnetted with /30. So that 30 you will see here. This is the actual network without subnetting for class C, and the subnetted network is this, and the IP address on the link is /32. This. Now this is an example configuration for IPv6 address on the port. Let's not get into IPv6 now, but I want to simply tell you, because they have written here, I just want to tell you. You go under the interface, same like what you used to do for IPv4. Description is not mandatory. You remember yesterday when I was trying to show you histories, I was typing description, means what that interface is about. You can leave it if you want. And then instead of typing IP address, you type IPv6 address. We usually type what? IP address. We usually type IP space address, and then we type the address. But for IPv6, you will type IPv6 address, and then the IPv6. address it, and then you need to bring no shutdown. As soon as you say no shutdown, you see the links comes up. That's all. Likewise, you go to another interface and configure another IP address. More detail we will see later. Now we are getting into very important stuff from now on. You see, static route. Afterwards, dynamic routing protocol. So better we'll keep it for another day because we are starting something important. We also need to do some lab as we learn. We'll keep it fresh for tomorrow. I'll stop here today. All right.